Hey guys, Dr. Ryan here. This PAT preparation video is sponsored by DAT Booster, the most powerful online resource for the DAT. So the perceptual ability test is the spatial reasoning portion of the dental admissions test. And I want us to tackle the PAT like a series of games. And we're going to unpack different strategies that you can use to win and confidently win these games. So the PAT has 90 questions in total and is made up of 6 subsections that appear in order with 15 questions each. And you'll have 60 minutes total to answer all of those questions. So there are 2 necessities when studying for the PAT. Number 1 is pure practice. Do as many practice questions as you can. And I strongly recommend checking out DAT Booster. I'll leave a link in the description for them. And the second necessity when studying for the PAT is finding strategies that work for you. So my goal with these videos is to present a bunch of strategies, and my hope is that one or more of them will stick with you so that you can be confident on test day with how you'll approach every single problem. You'll know exactly what to expect and exactly the steps that you'll take personally to solve each and every problem. So with that, let's get started. Hole punching, also called paper folding, is the section we'll cover in this video. Like all sections, it has 15 questions, and I recommend about 20 seconds per question for a total of approximately 5 minutes on this section. So this is another section where we can move rather quickly and save time for the more time-consuming sections. So for each hole punching question on the PAT, a square piece of paper is folded 1, 2, or 3 times, and then 1 or more holes are punched at specific locations. You are then asked to mentally unfold the paper and determine the final locations of the resultant hole or holes. So the paper is always folded toward you, in other words, out of the screen. Otherwise, you wouldn't be able to see all the fold lines if it was folded into the screen. The best way to really visualize this is to physically cut out a square piece of paper and do the folds yourself along with the question. The edges of the paper in the new position are represented by solid lines, and so you always know where the folds are going. And the original boundary of where the paper used to be is represented by this dashed outline. Every question in this section of the PAT utilizes a 4x4 grid system. Now I have to mention the grid isn't visible in the problems, but it's a no-brainer to use one for yourself because it helps to keep things simple. Each hole punch occupies 1 grid space, so there are only 16 possible places for a hole punch to go. So every answer will have somewhere between 1 and 16 hole punches in it. There are also 3 possible folds that can be made: a vertical fold, horizontal fold, and a diagonal fold, and they can be done to different degrees. The fold lines can be made along the grid line, like in the first 2 examples, or they can be made such that they split the grid system in half, like in these 3 examples. So you can notice how each individual grid space is split in half in these examples, which can make things a little bit more complicated because those types of folds have the potential to split hole punches in half. We'll cover this in practice problems later on. So here's my personal strategy in a nutshell. You first draw a 4x4 grid. Then you place holes from the last picture onto your grid. You include half holes in this. Then you find the line of symmetry and reflect holes over that line. Holes on the line stay where they are, and then you continue to work backwards through each fold until you get back to the start. So I physically drew out all 15 questions on test day on my scrap paper because it doesn't take that much time and it really helps you get to the correct answer quickly and confidently. So let's go through an example using this strategy. So first, we want to draw a 4x4 square. And people make tic-tac-toe grids, which is totally fine, but it takes a little bit longer to set up. I like using graph paper when I'm practicing, and then just draw a square that's 4 grid spaces by 4 grid spaces. That's because the scrap paper you're given on test day will most likely be laminated graph paper that you write on with a marker. So it makes even more sense to me to practice it this way and get used to paper that already has the grid laid out on it, and we're just placing a 4x4 square to outline what we need. So going into this section, I just drew 15 squares that were 4x4, so I was prepared and ready to go. So once we do that, step 2 is to copy the hole or holes from the last drawing into your square exactly where it was made. So we're going to copy this hole into our grid right into this space. We can tell it's not in the corner because it would be up here and actually be split in half if it were. And so it makes sense that it's going to be in that position. As a side note, I'd like to draw these as hollow circles because they take less time to do than solid dots. Now we continue using the same square. There's no need to keep redrawing it. We can continue to do our work in the same grid. So step number 3 is to find the line of symmetry of the previous fold. So the only difference between these two is that one has the hole and one doesn't. So there's nothing really to do here. So what we have to ask ourselves is, how do we unfold 3 in order to get to fold 2? Remember, we're working backwards now. And this is a crucial idea, that a fold has to be represented by one of the outer solid lines. So think about it. Anytime you fold something, no matter how you do it, that fold line will become one of the peripheral lines of your shape. It's actually pretty mind-blowing when you think about it. So for example, this piece of paper was either folded over this line, or this line. Those are our only 3 options. The way you figure it out is to determine where there's paper that wasn't there before. In other words, where the paper travels when you unfold it. So if we were to unfold it over this line, the paper would fill in area down here. Is that what we see over here in fold 2? Nope, so that can't be correct. If we folded over this line, we were to unfold this paper, it would fill in this little portion right here. Is that what we see in fold 2? Nope, so that's not correct. And then if we were to fold over this line, it would fill in this space up here. And that's exactly what we see in fold 2, so we know that's where the fold had to be made. So once you find it, think of that fold line as an axis or line of symmetry, which reflects everything to the other side. Then once you find it, think of that fold line as an axis or line of symmetry, which reflects everything to the other side. So what we can do is draw in the fold line or line of symmetry in your square. So we can copy that over just like that. And then reflect the holes across the line. So we're going to reflect this hole into this square over here. And just like that. And now you basically do this process again and again until you get back to the beginning. So let's go to fold 2 and look at how we can unfold to get to fold 1. So we have only 2 options here. We either fold over this line, which would fill in this amount of space. That doesn't make sense. Or we could fold over this line to fill in this space. And that's exactly what happens. So we know that our next line of symmetry is going to be right there. So that fold line is going to be right down here along the line of the grid. Now, interestingly, there are no holes being reflected over in this case. So nothing happens. And then for the final fold, we only have one option, and this will always be true. We'll be left with one possible option for the final fold to make it a complete 4x4 square. So we're going to fold over this line of symmetry. We can place that into our grid and then reflect those 2 holes over that line. And so that's our final answer. We scan the answer choices very quickly, and we can see that it lines up perfectly with B, and that's our answer. So to review, a fold has to be represented by one of the outer solid lines and determine where the fold is based on where the paper travels to when you mentally unfold it. Once you get accustomed to this method, if you want to save even more time and some mess when you do these problems, you can try not to draw in the lines of symmetry and just imagine them in your head. And again, I recommend doing this all in one square and using holes instead of dots in order to save time and space on your scrap paper. So feel free to pause the video if you want to work through this one on your own, otherwise we'll go through it together now. So for the first step, we just copy the holes from the final image into our grid. So we're going to copy this one and this one over. Again, there are only 16 possible places for them to go, so they're relatively easy to locate. So next we have to figure out the line of symmetry to get from 3 to 2. So we can see how paper is filling in the space down here. So we know that the fold has to occur over this line. The only other option doesn't make sense. So we can copy that over to our grid and then reflect the holes over that line. All right, and now we can move to the next one. So we see where the paper is filling in down in this corner, so we know that the fold has to occur over this line. So we can draw that line into our grid and then reflect the holes over the line. And step number 4 was to keep in mind that any hole that's already on a line of symmetry, you just leave it there. So we're going to leave that hole as it is. And then we finally go to our last fold, fold number 1. And we only have one option. There's only one outer solid line there, so we know it has to fold in that direction. And this one's a little bit interesting because it could be easy to say that it's this line here, but in fact, we know it's not because it would have to be this wide in order to properly line up with a column of holes. So we know that this line actually occurs midway through this third column here. So we can draw in that line of symmetry, and then that will result in all 4 of those light blue holes being transferred over to the right side. So we finished the problem. We have all of our holes represented, and we can see, we just scan through the answers very quickly, and we see that it perfectly matches up with answer choice D. All right, now for an advanced strategy. We have to keep an eye out for false holes, and false holes need to be erased from your drawing. Let's see what that's all about. So false holes or invisible holes are the one big exception to the previous rules. Essentially, they won't appear on the final answer in their original position. So we have to erase them from our drawing and be careful not to include them. And this is a great example question on how that works. So there are different methods for determining which holes are invisible, but all I do is add one quick little check step in our process. Let's start how we always do. We draw in the dots or holes from the last image. And we see that they're in that lower right-hand corner. They're not all the way to the corner, but they're one slot over. So we're going to copy those 2 holes just like that. And now we go to fold 3 and figure out how we can unfold it to get to fold 2. We see that paper is filling in this portion, so we know we have to be folding over this line. Here's another example of it being halfway through a column, so we can draw our line of symmetry like that, and then those 2 dots are going to get reflected over the line just like that. Now we check something. Are any of those previous holes on a part of the paper that is no longer there? So Obviously, these two holes are going to be on a part of the paper because that's where the fold ended up. But the previous two holes, one of them is just barely hanging on as a half hole. The other one is floating in space. There's no paper there after that fold was made. So this is very rare, but when this happens, we need to erase that hole. Or what I do is just place an X over it with our marker. It's a little bit harder to erase the marker on your scrap paper when you're there on test day, so I just like to place an X to make it nice and clear. So that's what we're left with. So now we keep going with the problem just like normal. So we ask how we get from fold 2 to fold 1. We had to fold across this line here, so we can draw that into our grid. And we notice that no holes are being reflected here, so nothing too exciting happens there. And then we have one option left. There's one outer solid line remaining. We're going to draw that line into our grid and then reflect any lines over. Now, interestingly, this one is already on the line, so we're just going to leave it be. And then the two on the left don't get transferred at all. And again, this one has been ruled out. That hole no longer exists. So we're left with only 3 holes, and that matches up perfectly with answer choice B, which is the correct answer. Notice how if we didn't catch that false hole, we would have been selecting answer choice E by accident. So this is tricky, but adding that extra check step adds hardly any time, and you can ensure that you don't miss any false holes. So after you reflect the holes over, just make sure that none of those previous holes that you had drawn are now on a part of the paper that's no longer present. And our final advanced strategy is to not get thrown off by weird folding. So we have folding in thirds, these little tiny folds, quarter holes, half holes, everything is fair game on the exam. But remember, the holes still can only be in 16 possible locations, no matter how you fold that piece of paper. So follow the same rules every time, and you'll get all 15 of these questions correct. So this is a pretty tough practice problem since the folding is a little bit convoluted, but don't get thrown off by that. Just approach it like any old question. Feel free to pause the video if you'd like to work through it on your own. Otherwise, we'll go through it together right now. So let's start like we always do. We're going to add these holes into our grid exactly as we see them. And then we're going to figure out where that first line of symmetry is. Now, there are a ton of options here. There's a line up here, here, down here, and over here. Now, of course, nothing's being filled in up here, so it doesn't make sense for either of those to be our fold lines. So we know that something has to be happening down on the bottom. We know that the paper is being folded into this bottom left-hand corner, so the only possible option for us is to fold over this line. Again, this is another example of folding halfway through a row, so we're going to draw in our line of symmetry like that, and then our holes are going to be reflected over that line. For the next fold, we know we're filling in paper in that bottom right-hand corner, so we have to fold along this line here. Let's draw in that line of symmetry, and then we're going to reflect only this hole over into that corner. And this hole we're just going to leave where it is. And then for our final fold, we only have one option, which is this line up here. We're going to draw that line of symmetry onto our grid. Again, we have one hole that's going to stay exactly where it is, and then one more that's going to get reflected over the line. And so we're left with 6 holes in that configuration. We go through the answer choices, and we see that answer choice D matches perfectly with our answer. So the answer in this one is D. So I'm confident that with all of these strategies combined and that step-by-step approach, you'll become a master at hole punching, and this will be one of your strongest sections on the exam. For more practice, sign up for DAT Booster for access to their special problem generators. The hole punching generator allows you to practice with unlimited questions, and you can clearly see where the holes end up after every fold to help you understand each question. You can even customize the difficulty level to your liking. I'll leave a link in the description of this video for you to sign up for their DAT Prep resource. Alright guys, that's it for this video. Thank you so much for watching. If you enjoyed it, please consider liking the video and subscribing to my channel for more on the DAT and all things dentistry. A huge thank you to DAT Booster for making this video possible. Thanks again for watching, and I'll see you all in the next video.